Hey everybody, Mr. Gajewski here, and today we're going to be solving a system of linear equations by elimination with multiplication. So we're going to have to multiply first here. So I have 4 different examples. Let's take a look at the first one here. So remember, when I want to eliminate, I want to make sure I have opposite coefficients. So that means same number, opposite signs. Now if we can't get opposite signs, that's all right. There's a couple different workarounds we can do. But for this first one, I have, well, a 4x and a negative 1x, a 5y and a negative 5y and a negative 2y. So for this one, I'm thinking what's going to be the easiest here? So multiples of 4 and 1, well, 4. Multiples of 5 and 2, it's going to be 10, but there's going to be a little bit more work involved in that one. So let's go ahead and let's multiply this second equation. Now, I'm going to have to multiply both sides. And I need to multiply it so that the coefficients of x are equal. So how can I make that negative x into a negative 4x? Well, I can multiply by 4. And remember, to keep my equation equal, I need to do the same thing to both sides. So I'm going to multiply both sides by negative 4. Negative 4 times negative x is negative 4x. Negative 8y, and 32. I'm going to go ahead and put a little strike through there. So I have 4x minus 5y equals negative 19. And actually, I'm going to go ahead and rewrite the first equation down below. Well, we have opposite signs of x, so let's go ahead and let's add these equations together. The x's are going to cancel out, and a negative 8y plus a negative 5y gives me negative 13y. And 32 minus 19 is going to give me 13. Go ahead and divide by negative 13. And y equals negative 1. Now I can go ahead and take that y, substitute for y in any of the equations. Now, which one, it doesn't really matter. So let's go ahead and I'm actually going to multiply, or I'm going to substitute in this equation here for y. So that's going to look like this. 4x minus 5 times negative 1 equals negative 19. Go ahead and simplify. Subtract 5. And divide. Go ahead and write your answer as an ordered pair. Always remember x before y. And if you want to do a check, you can substitute x and y back into both of the equations and do a check to see if you get a true statement. Remember, it has to work for both. So that's the first one. How about my second one here? Well, I don't have opposite signs here, but I have a couple different options. All right. I can take the second equation, multiply that by, take the first equation, multiply it by 2 to give me a 6x. I can multiply it by a negative 2 to give me opposite signs. Or I could even match up my y variables by multiplying by a 3 or a negative 3. Remember, the smaller the numbers, the better. So I'm actually going to go ahead and I'm going to multiply by 2. So my first equation, when I multiply by 2, that's going to give me 6x plus 2y equals 22. Now, 6x and 6x, those are the same signs. So I'm going to go ahead and I'm going to have to subtract here. So I'm going to put the whole thing in parentheses, minus sign out front. 6x minus 6x is 0. 3y minus 2y is y. And 24 minus 22 is 2. Let's go ahead and let's solve for x. And I'm going to plug it back into the first equation. So that'll be 3x plus 2 equals 11. Subtract 2, 3x equals 9. Divide by 3, and we get x equals 3. Go ahead and write your ordered pair for your answer and circle it up. How about another one? All right, so this one's a little bit different. Our equations are not written in standard form, and our variables are not lined up. So what we're going to do here is I'm actually going to rearrange this a little bit. I'm going to take this first equation, and I'm going to write it down here, and I'm going to actually flip those terms around on the right-hand side. So I'm going to have my negative 5x first, and my positive 15 second. Now I'm going to go ahead and I'm going to multiply to match up my coefficients. So for this one, well, what can I multiply here? Well, I could multiply the middle equation by 5 to match up my y's. And 2 and 5, well, I'm going to have to multiply both there. So let's go ahead and let's multiply the middle equation by 5. All right, well, 5 times y is going to give me 5y equal to, and let's not forget to multiply by 5 on the other side. 5 times negative 2x is going to give me negative 10x. And when I distribute the 5 to the 3, I'm going to get positive 15. I'll just draw this little blue arrow to remind us where this equation came from. So now I have a 5y and a 5y. Those are the same signs. So we're going to have to subtract here. That will give me 0 for the y's. Well, negative 5 minus negative 10x is going to give me negative, well, excuse me, 2 negatives is a positive. So negative 5 minus a negative 10, that's a positive 5x. And 15 minus 15 is going to give me 0, so plus 0. Well, what do we have here? I'm going to cross out that plus 0, so 5x equals 0. Divide by 5, well, 0 divided by 5 is going to give me 0. So now it's time to go ahead and solve for y. We can plug it into any equation. I'm actually going to plug it into the second equation from the original system. So y equals negative 2 times x, which is 0, plus 3. Go ahead and simplify. And 0 plus 3 is going to give me 3. And there is my solution. Just remember, if we don't have the variables lined up, go ahead and rearrange the terms so that they are. Multiply if necessary, add or subtract depending on the signs of the coefficients. And lastly, we'll do one example that involves multiplying both equations. So 2 and 5, there's nothing I can multiply 2 by to get me to 5. There's nothing I can multiply 3 by to get me to 8. So I need to think, what's a common multiple of 2 and 5? Well, I could get that to 10. Or I could multiply the 3 times 8 and the 8 times 3 to get me to 24. But those numbers are a little bit bigger. So let's go ahead and let's multiply the first equation by 5 to give me negative 10x. And the second equation by 2 to give me 10x. So my first equation, 5 times negative 2x is negative 10x plus 15y plus, or excuse me, equal to 35. I'm going to go ahead and distribute my 2 in the second equation. That's going to give me 10x plus 16y equals negative 4. Now these are opposite signs, negative 10x and 10x, so we can go ahead and add these equations together. The 10x's will cancel out. 15y plus 16y is 31y. And 35 minus 4 is going to give me 31. We can divide by 31, and we get y equals 1. Now we need to find x. Now I like positive coefficients, so I'm looking for an x that's positive, and the smaller the better. So I can pick really any one of these 4 equations, but the one I'm going to pick is actually this second one here. Positive 5x. It's the smallest positive x. So 5x plus 8 times y, which is 1, is equal to negative 2. Go ahead and simplify by multiplying 8 times 1. Isolate this 5x by subtracting 8 from both sides. And that'll give me 5x equals negative 10. Then I'm going to divide by 5. And I'm going to get x equals negative 2. And again, as always, I'm going to write my answer as an ordered pair and circle it up for my teacher to see. So in summary, we looked at multiplying one equation and then adding because we had opposite signs, multiplying one equation, then subtracting because of the same signs. Here we looked at rearranging the equation to line up our like terms and then multiplying. And lastly, we looked at finding a common multiple and multiplying both equations before we eliminate. That is it for solving systems of linear equations by elimination. I hope that helps, and I'll see you next time.